Hello, my name is Randy Boone, and in this video I'll be introducing the GRange parameter files. It's a limited number of files that inform the GRange software how to represent vegetation dynamics. And it's common across all of the LRange modeling families. So it's used in GRange, LRange, AFRange. These files are all used and they're behaving the same in each of the tools. Again, it's a small number, but still, if I talk of the individual parameters in each file, this would be a very lengthy video. And instead, I'll speak of the contents of the files in other videos. We'll begin with the simparm file. Simparm.grg is the simulation control parameter file. So it has the parameters that really control the way that the software is behaving. So again, accompanying these parameters, of course, are a whole suite of spatial data that help to drive the system as well. But this parameter file itself is describing where the system can find information, how it should be initialized. And often it is addressing where individual pieces of information may be stored and so can be edited to represent scenarios. Let me zoom in and give you an example. So here, for example, is the deciduous and evergreen vegetation cover. So this is tree cover, both the deciduous and the evergreen tree types. I don't recall the ST10 designation, why it's there, but you can think of these things then as potentials for scenarios. So if we had observed deciduous cover, for example, observed evergreen tree cover or total tree cover, then we can modify in a separate spatial surface, these are grid ASCII files, we could modify the amount of tree cover, either adding tree cover or taking it away, and then have a baseline scenario run using this file, edited the way it is now, and that would then represent a baseline to which we could compare against. Then you would go in, edit these two lines to point to the new spatial surface that you're interested in, run the simulation again, and you're able to compare the simulation with observed tree cover and modified tree cover and speak of whatever the scenario may suggest. And so simparm is really describing to the model how a simulation should be done. So for example, at the end of the file are the number of years, the range of years rather, that should be simulated. Next is outputlist.grg. Let's zoom back out and then switch to that file. And you'll see that it's a long list of the files that are produced, the monthly spatial surfaces that are produced from GRange. So these aren't model input, these are model output. So more than 100 surfaces that are produced every month by GRange, by LRange, by AFRange. And so this will vary between those tools. But I'll talk more about the specifics in another video, but the main point here is that if we again zoom in, you'll see that the initial column is filled with zeros and ones. And by changing these from 1 to 0 or 0 to 1, you're turning on and off whether the surface should be produced. Some of these files are large, and if you don't have space available or an interest in storing all of these outputs, you can turn them on or off. So you can see for, I've turned off day length in GRange, for example. Day length is not reported, whereas minimum and maximum temperatures are reported to check. Even though those are model inputs, they're reported as model outputs to ensure that things are being read correctly and such. Next is the driving file behind GRange, LRange, half-range. This is the land units file. Again, it could be named anything you like. So in a scenario, you may have a land unit scenario.grg or what have you. So you could have another name assigned to this file, but then in the simparm.grg file, you would edit to point to that new file. So maybe you have land units.grg for a base simulation, and then for a scenario, you have a different version that has plants responding differently to carbon, or a greater amount of C3 or C4 plants, or whatever might be of interest to you. And so this is a lengthier file. We'll talk more about it in another video, but it's repeated over and over. They're blocks. So here you see the suite of parameters, and you can see at the top, this is for tropical evergreen forest. If I scroll down, I go through all the parameters controlling that landscape unit, and the next is tropical deciduous forest. So again, I'll speak of that in some detail in another video. The next file is a legend, which is used with a separate spatial map, so a surface, that defines land cover. And so, a little strange, but in GRange, LRange, there are two main land cover maps, if you will, that are used. One defines the landscape units. So it's the one that says these areas are sufficiently homogeneous that I want to provide one parameter set to grow vegetation in a given landscape unit. The other is separate. It contains a land cover map in a more traditional sense, where it is allowing you to turn on and off different land cover types to be simulated. And so, for example, in this case, I used a source called Goji, which is a very detailed land cover map. It's cited in Boone et al. 2018. And it includes 99 land cover types. So again, quite detailed for the whole world. And you can see again that in this case, we have a column at the beginning of the file filled with zeros and ones, and it allows me to turn on and off simulation of whatever land cover type I might wish. And so, for example, I didn't want to simulate urban in GRange, and so I turned it off by putting a 0 there. I did wish to simulate areas that were designated low sparse grassland, and so it stores a 2. The dark forests are storing 0s, tall grasses, bare desert are storing 1s, etc. And so I'm able to designate which pixels within the landscape units are simulated by turning on and off entries within the legend file. And so, for example, in the half-range application, I decided to simulate the entire landscape, whether it was, literally the entire landscape, the entire continent. And so here, all of the land cover types are turned on. Next is fire data, which is indeed controlling fire data. As we'll talk about in another video, the fire is represented in one of two ways in GRange. Either it's represented probabilistically, where you can have each landscape cell have a probability that's assigned with a spatial map, but it's a separate affair from what's shown here. So we could have a map of probabilities of burning, extracted from MODIS data or what have you, and then that allows the system to represent burning of individual landscape cells. And if that is enabled, as it typically is in applications, then this file isn't used at all. It's just literally ignored. But if you enable the other pathway, you can use maps to schedule fires. And so there could be dozens and dozens or even hundreds of layers here designated in this file to talk about when fires occur across a landscape. So you could schedule fires for a given month in a given place and have that be simulated. Not used very often. Actually, right now, if you were to use one of these maps and analyses, you'd actually see it was where I did debugging. I wrote the word fire right on the landscape, and you'd see that effect. It was one of the ways that I knew that things were working the way that I wished. The next file is for fertilization. It's very similar. And so fertilization is managed in a way that's analogous to fire and a similar data set. So you can see here that I still have the fire designation, the fire surfaces used to test the fertilization aspect of the code. All of that information is in place in the code. It really hasn't been exercised a great deal, but by rights, it should be behaving reasonably. Potential for other kinds of scenarios. The last file is used in each simulation, and it is in regard to CO2 fertilization. So you're likely familiar with the prospect of CO2 fertilization. As we add CO2 to the atmosphere, the plants have an easier time gaining the CO2 they need to photosynthesize. And so we have increased production, especially around the northern hemisphere. Here it is the baseline file. I can share in another video other files that include increases in production. Here production is set at 80% of maximum potential, and it's repeated for every landscape unit, so you can just see 0.8s across the board through the 15 landscape units used in the initial G-Range application. And indeed, it's used the same for herbaceous, shrub, and tree, and for thousands of years, as I recall. Yes, it continues to the year 4000. And so this is the baseline. It's not changing the ways plants respond to increased CO2 at all. It's keeping it constant. But an analogous file increases this productivity as time goes on.